Good evening, one and all. I am A. Rajesh, Associate Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology, Hyderabad. It gives me an immense pleasure to welcome you all to a 6-day online faculty development program on emerging trends and tech challenges in cybersecurity, organized by Department of Computer Science and Engineering. Faculty development programs provides a wonderful platform for teachers and researchers to enhance their knowledge, exchange ideas, and also explore new dimensions in their fields. Such programs will help us to update with the latest advancements and innovative teaching methodologies. Ultimately, students will benefit in the academic era. I would like to express my sincere gratitude to our chief patron, Sardar Gagandeep Singh Kohli, Chairman, Guru Nanak Institutions, for his constant encouragement and support in conducting these programs. My heartfelt thanks to our patron, Dr. H.S. Saini, Managing Director, Guru Nanak Institutions, for his continuous guidance and motivation. I would like to thank our program conveners, Dr. Sanjeev Srivastava, Director, Dr. K. Venkatrao, Principal, and Dr. S.P. Yadav, Academic Dean of the Institute, for their valuable suggestions and support. My special thanks to Dr. B. Santosh Kumar, Head of the Department of Computer Science and Engineering, for his initiative and efforts organizing this faculty development program. Last but not least, I extend my appreciation to all the staff members and organizing teams for their continuous support in making this event. Now, on behalf of our institution, I extend a warm, hearty welcome to today's resource person, Dr. P. Naga Sravanthi, Assistant Professor, School of Engineering and Applied Sciences, SRM University, AP. Madam accomplished an academician, a researcher presently serving in the SRM University with over a decade of dedicated teaching and research experience. She earned her PhD in Computer Science and Engineering from Pondicherry Technological University with specialization blockchain mining and trust models for decentralized systems, a cutting-edge field that bridges blockchain consensus mechanism, network security, and trust computation in decentralized ecosystems. Madam, portfolio includes numerous SCI index journals, publications, IEEE conference papers, and 6 Scoopus index chapters. She has also filed and published 6 patents in emerging domains such as blockchain, IoT, and smart contract applications. In recognition for her academic merit, she qualified the Andhra Pradesh state eligibility test in 2022. A versatile educator, Dr. Sravanthi has taught a wide range of core computer science courses, including programming, data structures, operating systems, cryptography, databases, and blockchain technologies. She guided numerous students to extend their knowledge in blockchain through smart contract applications and is currently mentoring projects that integrate generative AI to enhance security and prevent attacks in smart contracts. Dr. Sravanthi is also a passionate academic leader, having delivered several faculty development programs and outward-based education training sessions and conducted hands-on workshops for students and faculty. Her sessions on blockchain-enabled learning environments have inspired educators to rethink classroom innovation through decentralized and transparent teaching models. Through her research, teaching, and mentoring, Dr. Sravanthi continues to shape the future of technology-driven education and trusted digital ecosystems. Once again, I warmly welcome all the participants and wish this FDP great success. Now I request our resource person, Dr. Sravanthi Madam, to start.
I'm very much delighted to be a part of this 6-day faculty development program on emerging trends and challenges in cybersecurity, which is conducted by Guru Nanak Institute of Technology. I would like to say thank you to the organizing team for inviting me as a FTP resource person on this online platform. Along with that, I would like to thank Anusha, Assistant Professor, CSA Department, for the continuous follow-up since the announcement has made. So thank you each and everyone. Now I'm very much excited to share my insights on the today's topic, Beyond Firewalls, Blockchain Intelligence Cybersecurity for a Distrustful Digital World. And before that, let me tell you what is the approach of a resource person to reach to the audience. See, being a resource person, my approach is to present this. My approach is, I would like to uh, I would like to conduct a kind of scenario where um where we connect blockchain with the cybersecurity to address contemporary challenges in the field of cybersecurity. In any research area, the first step of a researcher is to understand the existence and fundamentals of the area. Next, it is crucial to identify the key features of the technology and analyze how each feature can solve the real-time problems. Following that, we can explore the challenges, limitations, integrity of the other technology. In this way, my approach will be in further 1 hour. As a researcher or being a part of academic profile, our primary responsibility is to deeply understand the fundamentals. Secondary considerations includes the tools and frameworks available for simulation and experimentation. In my experience, nearly 80% of the successful research comes from a strong grasp of the basics rather than just problem formulation, simulation, or testing. With this perspective, I'm excited to start my presentation today, guidelining you through how blockchain can contribute to cybersecurity challenges. So, first we'll try to understand what is cybersecurity. Because now we are integrating blockchain into cybersecurity. We are talking about the emerging trends of cybersecurity. Means we are talking about the advancement of cybersecurity. So I have given 5 points. I think these 5 points are not enough to explain what is meant by cybersecurity. But still, I'm going to explain the basics. For example, let's try to understand what is meant by cybersecurity with general example. Imagine you're a student. You're going to school to check, you're a school student and you'd like to open your portal to check the grades. Okay. Here, what cyber security will ensure you is that it can allow you to see your marks. So here we are reaching confidentiality. That is one feature of the cyber security. And second thing is, no one cannot change your grades without your permission. Means there is a protection to your data. That is the second feature of the cyber security is called integrity. And the third one is, whenever you want to access the portal, you can access. That is called availability. So what I mean to say is, we are connecting to the internet every day since internet is booming. That means whatever the information we have, every sensitive information will be in the online, because instead of using our brains, we are using the entire data, including our sensitive data, personal data, whatever it may be, into the system. So in that case, what cybersecurity will do is it will protect our data by keeping all the safeguard things, and also it prevents things like phishing emails, malware, and fake websites that try to steal our data. So that is how we can utilize the cyber security. Now, in this slide, my research directions to the academicians are nothing but here we can work on three features. The first one is we can continue our research on the integrity feature of cybersecurity, and the second one is we can continue our research on the credentiality of the cybersecurity, and third but not least is we can continue our research on the availability of the cybersecurity. These are the three features we can continue our research. So what I mean to do is end of the every slide, I'm going to direct what are the research directions we can have the possibility to work in. And next, I have given an example for cybersecurity in the real time. Now, I'm getting to the cybersecurity definition because we can frame the cybersecurity definition in multiple aspects. First, I'm going to derive the definition in general aspect. Okay, so cybersecurity is nothing but it is a practice of keeping computers, servers, networks, data from unauthorized access. In simple words, we can say that whatever we are connecting to the internet, that it will protect. Here, what we are connecting to the internet, we have to make a question, right? So, every time we are connecting our mobile to the internet, we are connecting bank details to the internet, we are connecting Wi-Fi passwords to the internet. What I mean to say is, whatever we required in our human life, everything we are connecting to the internet. So that is called, we are connecting to the internet refers to. So here, cybersecurity, what it will do is, it will make sure these stay protected from hackers, viruses, or anyone trying to steal or damage our information, like our personal information, like our bank details, like our organization details, whatever the information it is. For example, if you look at the chat GPT, suppose if I'm trying to set something through Aadhaar card number, what chat GPT will says? Chat GPT will says it is an unethical practice. So what I mean to say is, in chat GPT also, it follows some kind of ethical practices. That's how it can protect the user information. So in protecting user information, cybersecurity plays a key role from every individual perspective and every organization perspective, because being a user, I have to protect my data. Being a organization has to protect the data. And being something, anybody has to protect the data. The whole responsibility is taken care by cybersecurity. So since the evolution has begun, we can securely save our data in the online platform. Now the cybersecurity has grown a lot, but now it is not the case. Now we have to design an intelligent cybersecurity. Intelligent cybersecurity system is different. Traditional cybersecurity system is different. Whatever the definitions I am deriving now, all the definitions are related to traditional cybersecurity. Now, at the end of this FDP 1 hour, we are going to think how to design intelligent cybersecurity, because we had to defend ourselves with online, because everything was digitized now. How to protect the digitized data, that we call defense, because we had to defense with the automatic tools, we had to defense with the intelligent models, we had to defense with so and so, that we call as intelligent cybersecurity, that we will talk about later. So as of now, what cybersecurity will do is, it will protect our data, that whatever we have connected. This is one definition. And coming to second one, CIA. Being a cybersecurity specialist, we might heard about this in multiple platforms, because, for example, when you're when you would like to allow a student for the placement, we will set a criteria, right? For example, if above 9.5 means the person is eligible for placement. Like that, in cybersecurity, even though it may be traditional cybersecurity or intelligent cybersecurity, whatever it may be, whatever the emerging trends we have in the cybersecurity, on the baseline, every cybersecurity should obey this rule, that we call as CIA. C means confidentiality, I means integrity, and A means accessibility. So first we'll talk about the research directions in this slide. Okay. So here, the confidentiality, integrity, and availability is the core principle of any cybersecurity governance. It may be blockchain, or it may be AI with cybersecurity, it may be ML with cybersecurity, whatever it may be. That tool should obey. And then it will provide some valuable directions to the researchers to work on it, because every time being a cybersecurity, we are not supposed to work on how to prevent the attack, how to detect the attack, how to store the data securely. We can also work in how to achieve this governance. This governance is nothing but CIA. So it guides them, it will help to the researchers to work in such a way that it will guide the researchers to focus on three essential goals. So any researcher can work on confidentiality. Here confidentiality means, as we says from the beginning, how to prevent unauthorized access. So user can work on, researcher can work on how to prevent data from unauthorized access or unauthorized attacks. And second research direction is user can work on integrity, because no one cannot tamper our data. That is called integrity. And third research area to the academicians we have is availability. Means whenever we would like to access server, that server should open. But here the problem is, if we keep the server continuously on, there are various possibility of attacks that we have to handle. So here keeping server on for 24/7 is one criteria. In that you have to work, but while working you have to address many challenges, like how to prevent the attack, how to detect the attack, how to automate the attack. For example, like what I have given, DDoS attack. There are many possibility for the attacks. I think you might heard about the research called software development network. In that area, we will talk about how to prevent the various kinds of attacks while the communication is happening. That is one separate research area. Like that, we are working here apart from the data security. So here from this slide, any researcher can have three kinds of research directions. Next, together these three directions not only will help the researchers to design the secure system, but also to set a clear roadmap for future research and innovation in cybersecurity. Let me tell you with an example. So far I am telling about the confidentiality is meant for to prevent unauthorized access. Okay, let me add one more point. You might heard about a breach, data breach that was happened in 2017. That data breach name was Equifax data breach. In that breach, what happened was nearly 140 million people data was exposed. 140 million people data was exposed. So here the problem is, because of the weak passwords, the data was exposed. So here researcher have to understand two things. One thing is, what is the experience he gained from that data breach, and second thing is, what is the research he can suggest to stop the problem. So if we talk about the solution, the best way is he can use either strong passwords or some of the encryption mechanisms to prevent this data breach. This is how we can analyze the situation. That is how we can come with the real-time problems in doing research. And coming to second one, integrity. Integrity, as I told, say for example, we let us take a smart system or IoT. In IoT, multiple sensors are collecting data. When multiple sensors are connecting with each other, my question is, are we guaranteed for the data integrity? We cannot, right? Because no one is not trustable. We are working in the zero untrustable environment. In that case, how can we assure for the integrity? So in the second case, so working on the integrity future is one direction of the research, and second way is, if we ask the researchers to work on the application, IoT is the one application. Because in IoT, while sensors are connecting to share the data, we can use integrity. So, for example, let us take a PhD student. Any PhD student can need to develop three objectives, right? In the first objective, he can work on the integrity. Second objective, he can work on the integrity related to IoT. In the third objective, he can work on the integrity with some other application. Like that, he can work to enhance his knowledge. And coming to availability. Availability is nothing but this ensures data and services are always accessible when needed. For example, if I said this system was not working 24/7, how can I say that that system is an efficient one? I cannot say, right, that what we learned from all the core subjects what we have in CSC. So to say any system is efficient, that too in online, by providing all the services to the user, we need to protect it from various services. Means, for example, here we can guide the researchers into the accessibility feature. That means he can work in the accessibility feature. And in the second way, we can also direct the researcher towards how to prevent the attacks, or how to detect the attacks. In that way, we can provide guidance to the researcher. The reason is that, see, for example, let us take a situation. I think in 2016, the DYN DNS attack, it will took down all the major servers. That attack name was DYN DNS attack. What that attack did was, it will took down all the servers like Twitter, Netflix, and many other for hours. The reason was that strong cybersecurity measures were used by hackers. Because of that reason, the systems were shut down for a long hours. It was a huge loss to the social media in 2016. So, whenever the server was shut down, there is a huge loss to the servers or data handling people. So in that case, here we need to handle many things. The first thing is, we have to ask the researcher in the availability direction, and second thing is, we have to ask the researcher towards how to detect the attacks or how to prevent the attacks. And in the third way, we can ask the researchers towards to work on a particular server like Twitter, Netflix, so on so. Like that, we can enhance the researcher knowledge towards a particular application. So finally, from this slide, I have given multiple research directions. So on three features we can work on it. First one, confidentiality, second one, integrity, and third one, availability. Followed by, when come to confidentiality, we can also allow the researchers towards the encryption mechanisms. And the second one is, we can also allow the researchers towards how to provide integrity in IoT ecosystem while sharing data. And coming to third one, we can allow the researchers toward how to automate the attacks, or how to prevent, how to detect the attacks. In that way, from the single slide, there are multiple research directions to a researchers. So here the thing is, everything lies on how we are going to understand the scenario. See, whenever we see the people, they are coming directly with the problem statement. See, what I mean to say is, coming directly with the problem statement is very casual. See, today in my apartment, the watchman didn't pick that waste. Then what happened? The clutter was outside only. It is not a problem statement. So here what I have to think is, there are multiple research areas to handle the clutter. Whenever the clutter was full, whenever the dustbin was full with the waste, because which includes dry waste and wet waste. So here my possibility of the solution should be expanded. The first way I can think like how to separate wet waste and dry waste. That is one way of the possibility. And second one is, even though it is a mixing of wet and dry waste, how to call the watchman whenever the dustbin was filled, instead of monitoring by human every second. Like that, we have to enhance the skills. So far, I have given two definitions to the cybersecurity in two aspects. In first aspect, related to CIA principle. In the first aspect, related to how to keep the system by protecting our personal data. Now, I'm going to talk the cybersecurity definition in third aspect too. The third aspect is very close to us, because even though UG, PG, even though from UG onwards, undergraduate standard onwards, we used to heard about these things, malwares, phishing, still the research is going on. When I was in 2011, phishing is something new, but still there is a great research on the phishing. So first thing you should understand what is meant by phishing, how phishing can steal the credentials, how phishing can steal the bank details of the user. Like that, you have to do the ground survey. Followed by, now we are in the 2025. Now you should think about how to do this phishing intelligence. That's how you can make the difference, right? Because now in 2025, we are living around a lot of technologies. If you take AI, Gen AI, machine learning, blockchain, quantum computing, everyone has its own scope. So now you should think, what makes this phishing more intelligence? In that way, you can carry the research. Suppose if somebody is coming with a phishing problem statement, you cannot say like this is a old statement. Of course, this is a old statement, but we can bring something new into the phishing. Like that, we can do the research. So here, again, in this slide, I am going to provide the cybersecurity definition from the attacks perspective. That is the first thing. Okay. And second, what are the attacks I am going to consider? Malware attacks, phishing attacks, and ransomware attacks, and zero-day attacks. Out of all these things, zero-day attacks are one of the most important as well dangerous attacks. Now in this 2025, everybody was talking about this zero-day attacks only. If you look at the Google Scholar, many publications were there in 2025 only on the zero-day attack. So now you have to start research. What is zero-day attack? How to overcome this? Next, we'll talk about the each one by one. As we know, cybersecurity faces many kind of attacks like what I have mentioned, but many people working hard to stop it. Of course, some people may could able to do it, some people may not. For example, if we take malware attack, this is a very dangerous attack. What it will do is it will slow down the computers. Okay. And second, if you take phishing attack, what it will do is it will send some fake emails or messages to the people to grasp their information without knowing them. That is called phishing attack. When coming to ransomware, so I forgot to say, ransomware attack is also one of the famous attack in the cybersecurity. Still, the great research is going on. But one thing, before we do research directly on the attacks, first you should understand where the attacks concept will come. Okay, attacks concept will come in the AI trade, that too in accessibility future. So whenever somebody asks you what is your problem statement, don't say your problem statement that I'm working in so and so attacks. No, it is not the case. You're working on which feature? Accessibility. In accessibility, there is a possibility for the attacks. You have to say like this. Okay. And next, here, if we talk about ransomware attacks, what it will do is it will log the data until someone will pay the money. So what we had in WannaCry attack, you might heard about WannaCry attack. I think that cyclone name Monta, what we had very recently. Here also the attacks name were very different. If you look at the industry, they are coming with the different attacks like Microsoft Azure, WannaCry, breaches. There are various kinds of breaches. But the thing is, no need to be particular to the particular attack. No need to be particular to the particular attack. You should be particular to the where attacks will come. If you catch this point, the next point will be easy for you. Okay. Even you can also introduce new kind of attack. You can name it with your name. That is how research is going on. Okay. And here I can say that the ransomware attack is very similar to WannaCry attack, which we had in 2017. And next, even employees or partners and can cause harm by mistake, like clicking on unsafe links or sharing data with the wrong person. The most dangerous attack is zero-day attack. See, suppose if we click on something that we don't know, what happened? Unknowingly, we are going to lose our data. We are going to expose our data to hackers. All those attacks will come under zero-day attacks. So, being a human, every day we are connecting to the system to do various activities which we cannot do by brain. In this aspect, we are doing many blunder mistakes. All the blunder mistakes like clicking unknown link and sharing some unknown information, all these comes under zero-day attacks. Now in 2025, we are all doing those mistakes only because of the time busy. Now, this zero-day attacks having great influence on the hackers to steal our personal data. That's why now all the hackers were training on the zero-day attacks only now. Suppose if you watch the latest movies, Hollywood movies, some scientific movies, they're working on the zero-day attacks only right now. This is a trend of hacking techniques, right? Next. So far I have given three definitions for cybersecurity. One on aspects, common aspects. Second one on CAI, right? And the third one on attacks. So coming to the research directions, from these three slides only, we can expect number of research directions and to enhance the research in cybersecurity. So far, I didn't talk about the challenges in cybersecurity. I'm talking about the advantages of cybersecurity only. Okay, now we'll come to the fourth slide. In today's world, every time you're with the internet, either to swipe a card, either to log on to particular application, either to book something, or either to do so and so. So every time we are with the internet. So here what happened after being with the internet, we are doing digital battle. We are doing digital battlefield where invisible cyber threats are always active. Suppose if I ordered something in the Swiggy, do you know, is there any safety for my credentials of the credit card? We don't know, right? So every day we are doing digital battlefield. Remember these words? These words are buzzword nouns. Buzzword now because of the booming technology, especially after this AI existence. So every time being with the internet, we are doing digital battlefield where invisible cyber threats are always active. We don't know who are active. So hackers and malicious programs constantly monitoring our personal data, our bank details, our confidential information. That's where cybersecurity comes in protecting our system. So here what I mean to say is, in this point, after starting being with the internet, we started to store everything in the online. That's okay. Second point is we have started doing digital fighting with the unknown hackers. That is also okay. But the third point is here, whatever the benefits we had discussed till now, those things are going to vanish. Now there is a chance to address what are the cybersecurity problems. Now researchers are looking into what are the challenges in cybersecurity. That's where people started thinking. Okay. So, for example, let us take the same example in a reverse way. Earlier, what I said, suppose if student is able to see his grades, that is called confidentiality. Suppose if the student is uh, not tailored other person to modify his grade, that is called integrity. Suppose if the student could able to access his grades 24/7, that is called availability. Earlier I had given the definition like this when I started explaining about the cybersecurity. Now I was into cybersecurity pitfalls. Now in this scenario what I am telling was, if the attacker leaks a patient's record, here what happened? The confidentiality is lost. Attacker don't have the access to the patient record, but he accessed the patient record. Here what happened? Unauthorized access was happened. So data was lost. Next, integrity is broken. After accessing the patient information, what attacker did was he applied for the fake insurance. Then what happened? He tampered our data. Integrity is broken. Next, the third one is if the hospital server goes down. What happened? Immediately, we can't apply for the insurance once the patient was died. We have to wait the server uptime. Meanwhile, what happened? The attacker can claim for the patient insurance. So, if we talk in a positive way, the things were different. But if we talk in a negative way, the things were different. This is what I would like to conclude from this slide. So here you have to understand one thing. Being a person, every day we are connecting to the system, but do you know per a second how many attacks we are facing unknowingly? Unknowingly, there are number of attacks that we are affected with our shared data. We don't know. If we want to name one by one, even I think 1 lakh names are also not enough. That many attacks we have. Okay, that's all about the conclusion from this slide. Now I started explaining cybersecurity pitfalls, drawbacks, right? Next, we'll go to the next slide. My question is, so far we have been talking about why cybersecurity is very good. It will keep our data secure and safe. It will provide integrity. It will provide accessibility. Like that we had discussed, right? But now my question is, why it becomes so challenging? Because we have hackers outside, we have technology outside, we could able to create a strong passwords outside, right? Then what is the problem? The problem is not only single problem, there are multiple problems. The reason is that, first look at the first point, increasing digital dependency. See now, earlier we used to cook at our home. Now, instead of cooking, we relied on Swiggy, we relied on Zomato. Every time, instead of booking on Swiggy and Zomato, we're also checking for the discounts. So what happened? To order one item, we are looking a screen for an hour, 2 hours, 3 hours. So what happened? Whatever the need it was, we are continuously dependent on the digital platforms. That is where cybersecurity becomes challenging. Okay, and second one, rapid evolution of cyber threats. I think you might heard about AI intelligence system, Gen AI. When all this came into picture, even we can also talk about quantum computing. All these technologies having the capability to break the existing technologies. So if I ask you a question, machine learning is best or quantum computing is best? Obviously, what is your answer? Quantum computing is the best because it having good potentiality to break the system. Quantum computing can break the blockchain. Quantum computing can break the machine learning. It can also do many other things, right? So because of the rapid evolution of technology, the threats becomes more. The threats becoming more and more day by day. And the third one is AI based attacks. See, you might heard about smart contracts. Of course, I was not into smart contract yet, but still let me tell you. There is a concept called smart contract in blockchain. What it will do is it will automate the things. For example, let's take a student and a teacher. Student will select the teacher for the training. Whenever the training completed, the payment was automated. Here the automation is the speciality of the smart contract. The thing you have to understand is we can do the automation by using AI technology also. But here we are doing automation on blockchain. It means what happened was whenever the training was completed, the student provides feedback on the network. That feedback was immutable. That cannot be edited. This is one aspect. Now we'll talk about the AI. In AI, for example, if we design the same problem statement in AI technology, what happened was the student can pay to the teacher after completing the training. But the thing is, here he cannot store the feedback on a network. He, based on the interest on the teacher, he will pay the money. Suppose he likes the teacher more, he will pay more money. Means by using AI technology, we are personalizing the things. By using blockchain technology, we are securing the things. There is a great difference, right? So because of the number of technologies, what happened was there is a growing demand of attack methods. That is one other security challenges. See, earlier, if somebody is working on the cyber security means they used to keep talking about encryption, decryption, cryptography like that only. Now it is not the case. Now everybody talking about how to design the intelligence system, how to design automatic tools, how to design some AI tools like that. The scenario was changing. Am I right? Next, lack of skilled cybersecurity. I think we might heard about a red hat, black hat hackers and all. I think those are may not be capable enough to break the blockchain. Because if you take blockchain, what happened was we can transfer the information or we can share the transaction from two persons, but we don't know who are the two persons because we are not going to store the sender information as well receiver information. In that case, suppose if we ask the hacker, how can he get the details of the sender and receiver? He cannot write. So what I am telling is hackers are also are lagging with the skills. That's what I can say. And the third one is very important one, human factor. See, whenever I was logging into something, I'm asking the system, please keep remember my password. That is where we are completely bending on the digital system. That is where it is a burden to the cybersecurity. That is where the challenges in cybersecurity becoming more. That is the reason why now today we are talking about the emerging trends in cybersecurity. If it is not the case, it is not necessity to talk about emerging trends. Cybersecurity itself is a challenging. Cybersecurity itself is a special. But because of all these things, now we are talking about emerging trends in cybersecurity. That's what my conclusion. Now, major cybersecurity case studies. We might heard about many case studies. Even when we teach particular subject in a student related to cybersecurity, hands-on, so open source technologies, we used to discuss these incidents with the students. But what happened was they used to understand what was happened, what is the experience of the people. These two things only were there in their mind. But now, when we discuss the same experiences to the academicians, here my suggestion is, of course, this was happened. For example, let us take WannaCry ransomware in 2017. It was happened. Okay. But now, if you want to enhance your research in cybersecurity, first you try to analyze why it was happened, how you can prevent it. In that way, you can enhance your skills, right? This is what I would like to conclude from this slide. So again, in this slide, I have collected all the cybersecurity case studies which have majorly affected the system from 2017 to 2023. Okay. First, we'll discuss about the WannaCry ransomware. Okay. As you already know, this was one of the global ransomware attack that spreads across more than 150 countries. It affected hospitals like the US, UK, railways and telecom companies by encrypting their files and demanding payment to unlock them. This was happened. So, WannaCry ransomware attack, it will demand the people to open their files by encryption. Actually, file is mine, right? Who the hell to encrypt my file? Again, they're demanding some money. This is what happened. Now, I'm asking, being an academician, what can you do to stop this from the next time onwards? Can we do anything? Yes, we can do. That is called research direction. So, we can develop some better models where automatic patch updates and backup recovery system to avoid data loss. Somehow we made a mistake, right? So to stop this from the next time onwards, here we can we can do some kind of we can develop some kind of detection models, automatic patch updates and backup recovery system. So what happened was, for example, whenever you are trying to backup your data, you are not leaving even single bit of data also to the hacker for the possibility of hacking or for the possibility of encryption. So here the research direction is you need to develop a good detection models and backup recovery system so that it will not come next time. Next, SolarWinds supply chain attack. And this is also one of the major attack. And what this did was, hackers included malicious code into the trusted software. So, and again, this software was installed by many governments and corporate networks and giving attackers secret access because some of the government institutions wantonly given access to the attackers secretly. This is what happened in reality. Now, being a researcher, what you can do here, there is a mismatch among government employees, corporate employees, hackers. So here, being a researcher, if you develop a supply chain transparently, What I mean to say is we can design a transparent supply chain. Here, whatever the attacker is doing, that is visible to corporate person. Whatever he is doing, that is visible to government employee. So there is no possibility for injecting malicious data. That is how you can work here. And if you look at the AI generated phishing, deepfake attack, this is one of the worst attack that we ever talk about. Okay, and what this attack was, by using AI generated voices and fake emails, it will trick the employees and collected money for a social cause. Actually, that Microsoft company not collected any money from the company, but by using AI voices, AI meetings, online meetings, it will the employees were cheated by AI technology, and within 1 hour they have collected some billions, millions of money for the social cause. So this is one of the biggest attack. So here what we can do is, whenever we have some online meetings, we need to design AI phishing filters or deepfake detection tools or voice authentication tools. You can work on these 3 ways. Here the problem is, when this incident was happened, the employees were thinking that voicemails and that voice online meetings were connected by real CEO only. They thought like that, but actually all the mails and all the voices are by AI. That's where we can develop voice authentication techniques here to get out from the AI trap. This is one way. And coming to Aadhaar data link, this is very, very sensitive because it will collected almost 1.1 billion Indians data and expose it to weak databases. And coming to AIMS cyber attack, this is also one of the major attack in India. It was hit by ransomware. Actually, what happened is, because of this attack, and the hospital services were delayed for a long hours. So here what we can do is, to prevent this attack next time in the healthcare, we can provide some kind of healthcare IT security. That's where I think the blockchain can be implemented in healthcare, and quantum computing can be implemented in healthcare. Because if the services to the patients were delayed for a long hours, what happens? There might be a possibility for their death. To prevent this, we need to provide IT services which are very faster to save their lives. This is how you can think. Like that, there are various case studies, and in summary, I can say all these case studies are telling about how cybersecurity threats are evolved, and how evolved from normal malware to AI driven attacks. Initially, we talked about malware phishing. Now we are talking about AI attacks. So, every time, whenever the technology is going upwards, there are various possibility for the attacks. So here, instead of gaining experience from the attack, it is the responsibility of the researchers to prevent the attack without happening in the next time. And next, cybersecurity ecosystem. Here also there are a lot of research directions. Ecosystem in the sense, in the beginning of the internet, I think we might use firewalls, right, for protecting our computer from the outside world. Later we may use some coding, and then we may use some encryption algorithms. Followed by, we have used biometrics, and after that we are using some zero trust models. Right now we are using automatic tools. Like that, the evaluation is going to change every time. In 2025, the evaluation was completely relied on AI, blockchain, quantum computing, that we call as a trade. Three technologies will together will protecting data in cybersecurity ecosystem. But if you look at the firewall, whenever the internet begins, firewalls are the only option for protecting our system. What I mean to say is, if you would like to work on the firewalls in cybersecurity ecosystem, you can work, but you have to come with, see, for example, if you would like to work with the firewall, here first you have to change your mentality. Here you are not working with a firewall, you are working on the network security. That you have to understand. So if you say you are working on the firewall means it is outdated. Suppose if you say if you are working on the network security means it's something new. See what happened was earlier we are using firewalls to provide to protect the security, right? After that, we are using some IDS and IPS mechanism to protect the security. So now also you can include some kind of AI technology into this network security to protect the system. Like that you have to work. And we can talk about data security also. Data security means how to protect our personal and company information through encryption and decryption. I think for encryption and decryption, we have a lot of technologies and a lot of algorithms. But now, those traditional algorithms are also brokered by quantum computing. Now, what I mean to say is, if you want to do the research on data security, you can do. But the thing is, here, to provide the data security, we have to use quantum computing. That is how we have to change the scenario. So, out of the given ecosystems, the two things are very, very important. Those two things are cloud security and data security. These two are evergreen and evergreen technologies which would like to enhance your research. Because if you look at the cloud security, I think everybody knows it keeps our data online and services safe using secure APIs. It keeps our data online and it services whenever we need. But by the time of deploying data to the client, it will follow some secure APIs. But my question is, with the secure APIs, with the traditional cloud architecture, can we guarantee for the integrity of the data? We cannot write. Here we have two actors. One is the cloud provider, other one is the client. We cannot guarantee on these two actors. So we have to go for zero trust. Whenever I say zero trust means in the zero trust, no one is there to protect your security. Then what is meant by zero trust? Zero trust is all about blockchain. Zero trust is all about first add and then verify. If it is valid, then that will be added to network. If it is not valid, that will not be added to the network. So here in the zero trust, we can no need to trust anyone. Simply, we can do whatever we want. No need to trust anyone. That is called zero trust. So now in 2025, there is a great demand for data security in quantum computing, cloud security in zero trust models. These are the two research directions I can suggest to your researcher. And next slide, current research directions in cybersecurity. And even if you see the Google Scholar also, now many publications were related to this given list of topics only. Because when presenting current research directions in cybersecurity, it is important to explain what each direction means, right? For example, the first one, AI and machine learning for automated threat detection, right? Researchers are now using AI and machine learning to identify cyber threats automatically. These systems can learn from patterns in a network data and detect attacks faster than humans, right? For example, what are the transactions I have done in the last month? Means in the last month, what is my pattern of transaction doing? In this month also, if you know what is the pattern of my transaction, you could able to detect the threat which may occur. Okay, suppose the threat was occur, then what happened? You can use AI technology to prevent that threat by using some threshold and all. Like that, we can design this kind of research problem in 2025. And next we can see, which is very, very important, the fourth one, IoT and edge device security. With the billions of connected devices, IoT is all about smart system. With the billions of connected devices, from smart homes to industry sensors, providing security to each connected device is essential. For example, preventing hackers from controlling smart cameras or medical devices. Let's take an example. I have camera at my home. If somebody is accessing my camera without knowing me, then what happens? There is no security, right? So here we can provide lightweight encryption, secure firmware updates technologies to encrypt the data in my camera. So in that way, to secure my camera data, I can use cybersecurity here. That technology we call as lightweight encryption protocols for firmware updates, or we can also call this as a edge level intrusion detection system. This is also interesting. And coming to third one, this is all about our blockchain, zero trust architecture. Zero trust architecture means never trust, always verify. As I said earlier, no need to trust anyone, just try to verify. That's all. But here the problem lies. That problem is to verify particular data that should be more energy efficient. So again, we have to work towards the sustainability. So if you want to extend your research in zero trust architecture towards the sustainability, you can also extend. That is up to you for anyone. And the last one, which is very emerging now in 2025 mid onwards, that is post-quantum cryptography for future proof encryption. Now, quantum computers were named to break any kind of hashing methods, right? For example, I'm going to design an algorithm to save my data against future quantum attacks. Okay, I have to design algorithm to save my data against future quantum attacks. Is it possible? Of course it is possible. The thing is, first we should understand how quantum computing would able to break the hashing. If we know this, we can design anti-quantum computing model to save your algorithm for future quantum attacks. Okay, so first we should understand what is the algorithm it follows. Like that, all these are the current recent research directions in cybersecurity. Anyone can work in any one of the given direction. And finally, here I have given some of the websites. I think many of you might know about Kaggle competition. That is a website. In that website, we will get, that website is mostly related to Kaggle competition. That website is mostly related to provide current to data sets, to provide what are the trending data sets, and it will also provide the dashboards to the participant. It may be student or any academician. That website will allow the academicians to participate in competitive environment. So whoever win the training and testing modularity, they will get some reward. They will be on the top rank on the dashboard. That will be used for the placement purpose, especially when you go for machine learning related companies. Like that, it will help us. In the same way, if you would like to work purely on the cybersecurity, first we need data set, right? Without knowing data set, without knowing what is our data, how you can continue research, we cannot. So to know what is the data availability on cybersecurity, these three platforms will help us to get the data sets. Or else, suppose if you would like to work with only ransomware attack, it was happened in 2017, right? WannaCry attack. If you want to get the data set of that particular attack, these three platforms will help us to get the data set. And third case, if you would like to train and test the data set by including machine learning and AI, again that data set will help us. So these three platforms are really will helpful to any kind of researchers who wants to do the research in cybersecurity and other integrated technologies. Only to get the data. Next, now I came to the point. I have given much information. Initially, I started with cybersecurity is good enough. Then I came to conclusion that cybersecurity is not enough to handle the security of the data. That's where I have started including AI and ML, right? This is the conclusion till now what I have made. Now my question is, with AI and ML, why cybersecurity is not able to secure the data? That is the biggest question. The reason is that even AI and machine learning have greatly improved cybersecurity by helping systems for designing, detecting threats faster to analyze huge amounts of data and to automate responses. Even though by doing all these things, they're not enough on their own because several challenges existed. These are the challenges. That's why AI and ML are not enough to secure the data in cybersecurity. So those challenges, for example, imagine a cybersecurity company using an AI-based intrusion detection system to monitor a bank's network. Okay, we are using intrusion detection system which is based on AI to monitor a bank network. Every second, can you guess how many transactions we have from different persons? Number of transactions, right? So every second, thousands of data packets flow through the system. So now, by using AI to detect unusual patterns or attacks in the real life, the AI model must process this data continuously. We have to run the model continuously around the data. So my question is, running such model takes how much computational efforts? I think that's what made the difference between deep learning and machine learning. Compared to the training difficulty in machine learning, the training difficulty in deep learning is more. We have to put more computational efforts, right? This is one place where we are using blockchain. AI and ML are not sufficient. And second one is centralized data control. For example, uh, whatever AI and ML so far we're discussing about, all are talking about centralized systems. Okay, they will create a single point of failure that hacker can target. Okay, hacker can target. Suppose if whenever student wants to access the ERP system or attendance system, if it will fails, what happen? He cannot access. That is a major challenge. But of course, by using AI and ML, he can personalize the things, he can recommend the things, he can automate the things, but he cannot avoid single point of failure. So third one is data privacy and integrity. So here it uses training data. We can train the data and test the data on multiple ways. For example, if we take a support vector machine, we can train on linear data, non-linear data, but that's not an issue. The issue is how can we assume that the data is correct data? Are we guarantee for the integrity? We don't know, right? Because the data may be coming from multiple factors. For example, if we take federated learning, when we deploy data on a shared basis to the multiple clients, how can you say that the data is secure enough? There is no guarantee because we cannot trust the client blindly. So even though we have training and testing in AI and AML, we cannot say that the data is secured one. The data is integrity one. This is another challenge. And coming to transparency, I think in the previous slide we had a discussion on transparency. I think at some point of attack, right? Their attackers and government employees, corporate persons, or together they have imported some attack into the software. That is what we had discussed. But now, if you're having the transparency in decision making model, do we have such kind of attacks? No. So here I can say to provide transparency in designing a model, to provide integrity in the data set, to avoid centralization failure in cybersecurity system, and to avoid high computational requirements in Gen AI and AI, we need to include something that is called blockchain. That is called blockchain. Again, I'm repeating, to avoid centralization failure, to provide transparency, to provide integrity, especially the last three features. All these 3 points are related to three features of the blockchain. We have to integrate blockchain into cybersecurity. That's all. Because earlier we have seen, because of no such features, there are multiple attacks in the cybersecurity system, even though we have AI and ML. But now, with these features, we don't have such attacks. Now, first, instead of telling about what exactly the blockchain is, let me just make the sequence once. Initially, I have started with what is cybersecurity. Then I came with what are the challenges in cybersecurity. Then I came to why AI and machine learning are not enough in cybersecurity ecosystem. Now I came to need of integrating blockchain into cybersecurity is important. Now at this point, right? Now in this point, let me tell you the integration of blockchain technology with other emerging areas is very much crucial in cybersecurity. That's why instead of giving the blockchain definition directly, first I have listed all the features of blockchain. Suppose if somebody asks you, for example, let me take my case, I have worked in consensus mechanism. This is a feature of the blockchain. So this is my future, working future throughout my PhD. So like that you have to explain. So here what I am telling is whatever the future it is in the blockchain, we can integrate these features with artificial intelligence to make the cybersecurity system transparent, to make the cybersecurity system zero trust, and to make the cybersecurity system intelligent, and to make the cybersecurity system verifiable and open to other frameworks. Here we can blindly allow the persons to access our system when we after integrating these features. That's what I can conclude. Now we'll look at the blockchain definition. This is the simple definition. Let me tell you what exactly the blockchain is. Blockchain is a decentralized digital ledger, meaning it stores information across many computers. I think in the previous slide we had a discussion on single point of failure because everywhere we have centralized system. Even after having AI and ML into the cybersecurity, there is a possibility for centralized failure. But now it is not the case. Here, we are using multiple systems to keep the same data, like what we have in the ledger book. So if one system fails means we can get the system from other system. That is a flexibility we have. And in blockchain, whatever you are going to store, in cybersecurity, we are going to store the data, right? In blockchain, also, when you are going to store the data, that data will be considered as a transaction. Second point. So, and when we are adding transactions or when we are securing data in blockchain, that will be treated as a blocks. So suppose if you ask me a question, what is meant by block? Block is nothing but a collection of transactions. What is meant by transaction? Whatever the operation you are going to do on the network, that is called transactions. In cybersecurity scenario, we are going to store the information in the digital system. For example, when I am going to open my Gmail, my password and my Gmail or the information, those two will be considered as a transactions. Those two will be stored onto a block. Okay. Now my intention is to explain. My intention is I'm going to tell you this block is common to multiple systems. If one system fails this block, we can also get the same block from different systems. Like that, we can keep the blocks among the systems. Next, whenever the particular data was created, we have the timestamp for the block. In blockchain, one of the best feature is, look at the earlier screen. In the blockchain, one of the best feature is immutability. Immutability means once the data is recorded, that cannot be edited. So whenever the transaction was added into the blockchain, that cannot be edited because every transaction contains a timestamp. Now I'm delivering as a resource person at what time? At 8:10, right? That is a timestamp. Now at this time, now I'm delivering a content that will be added to the blockchain along with the timestamp followed by cryptographic hash. So here every blockchain will follow SHA 256 algorithm, means whatever the action I am performing to that action in this particular timestamp, it will provide a hash which is of length 256 length. 256 length. So all this information will be recorded onto the blockchain. So that what I am going to conclude is it will works, blockchain will works without a central authority like what we are seeing in the bank and railway stations. Instead, it uses zero trust policy, which means it will without third party, it will verify the data, it will keep the data safe, and by doing many other things. So far, what are the problems we have discussed in the cybersecurity? We need third party to store the data, right? But now in the blockchain, we need not to trust the third party. Here we are following a policy called zero trust. That is a simple thing why blockchain is important in cybersecurity. It will vanishes all the problems of cybersecurity. Even though when cybersecurity integrates with AI and machine learning, whatever the problems we have, all the problems are overcome with the blockchain only because of the features. If you look at the decentralization, we have the same information on multiple systems. If you look at immutability, once data is stored, that cannot be modified. If you look at the transparency, so whatever action we are doing, that will be visible to everyone. And if you look at smart contract, that can be used for to automate the process along with the immutability. But if you consider the same smart contract in AI technology, that will be in a different scenario. There we can do the automation, but we cannot, we can do mutability, means we can do editing. But here we can do automation followed by editing. We can do automation followed by immutability. No one cannot modify the data. So finally, because of these features, we can integrate blockchain into cybersecurity to achieve zero trust verifiers. That's all, a simple conclusion. Now, let me tell you with one example how transaction is going to add to the blockchain network. So I will show you this diagram. So we'll see. For example, I'm going to add a transaction. I'm going to perform a transaction. Let us consider two cases, A and B. A wants to send 500 rupees to B. Here, whenever A would like to send 500 rupees to B, A will be recorded with one hash value. That hash value we call as a Merkle root. Okay, and B will receive that 500 rupees. Whenever B receives that information, that will also recorded as with some hash value. So here A hash value, B hash value will be recorded under Merkle tree. In blockchain, if you want to do in-depth research, you can go with the Merkle tree. This is very difficult research in the blockchain. What it will do is it will stores all the transactions communications, or it will stores all the transactions connectivity by storing transaction information. Next, when I would like to send 500 rupees to person B, at what time I would like to send, that information will be stored at timestamp. Next, when I would like to send 500 rupees to person B, here I have a doubt that is the person is having 500 rupees with him, or will he may give it to some other person. I don't know. Suppose if the person he may give it to other person means he don't have the 500 rupees with him right now. That's why while performing some action into the blockchain, while recording some action into the blockchain, we need to check the person previous actions also. Suppose if he do not do so means he having 500 rupees with him, he could able to give that 500 rupees to person B. Suppose if he already gave 500 rupees to some other person means he don't have 500 rupees. That's what meaning of the previous block hash. And next, every block having some version. Suppose there are number of platforms, as I said in the beginning, no need to think about the platforms like Hyperledger, Bitcoin, Ethereum. There are a number of platforms. Each one provides a different version. Just forget about this. And coming to nonce. Nonce will tell you what it means. So finally, these three are the details that we will consider while storing any transaction into the blockchain. Okay, with these three together can create a block, and now for this block we are going to provide a SHA-256 algorithm. This algorithm will provide a hash value to the block. Now my question is, the block whatever it was created, is it correct block? Because so far we have not taken permission from anyone. How can you say that it is a correct one? As I said in the beginning, blockchain itself works in decentralization. So here you might have question in this. You might have this question in your mind: who will do authorization of the block? Now I will come to the point. Nonce is the person that will do the authorization of the point. Initially, whenever the block was created by one node in the blockchain, the nonce value is 0. Okay, based on this nonce value 0, in which system we have created this network? Based on the system configuration. For example, my system configuration is 64 GB. Then based on that, target value will be created. Now, the entire block heading process was done by only one user. Am I right? Now, to check the authorization, we are involving the remaining nodes. So, every time in the blockchain, during block creation process, one user will create the block, remaining users will verify the block. How they will verify the block? By adjusting this nonce value. Initially, what is the nonce value at the time of block creation? Nonce value 0. But at the time of verification by remaining nodes or remaining users, this is a terminology. We can call them as a miners actually. Remaining miners, they will adjust the nonce. They will adjust the nonce which is less than target. Initially, I said as per my system configuration, my target is 10, for example. Suppose if all the miners will get 10 means that is authorized. If they get 9 means that is not authorized block. So they won't add this to the network. Like this, block will be created. If you observe this, the data is permanent. Once it is added, that is on the network, no one cannot do any editing operations. Second thing, here the entire data adding operation done by using zero trust environment. Means one person will acting the data, other persons will verifying the data by considering multiple factors. This is how block will be created. This is how we can achieve blockchain into cybersecurity for enhancing more secure system. And coming to so far I'm telling about some people will verify the data. One person will create the block, other persons will verify the data. I'm telling the same, right? But now I'm telling another thing to you which is new. One person will create the data, that's okay. While verifying other persons, while this was verified by remaining persons, there are number of consensus algorithm. So something new to you is consensus. Consensus is one of the feature in the blockchain. What it will do is it will take in authority. It will implement different policies. Okay. Suppose today FDP was scheduled to 7. It was scheduled by the organizers. By the time I should log in. In the same way, consensus algorithms are available, almost 130 algorithms, each one having its own policy. So whenever we would like to add a block to the blockchain, we can implement any one among the 130 consensus algorithm. Now what consensus algorithm will do here? Consensus algorithm will help to the miners to come to an agreement. Our consensus algorithm will helpful to the users to come to an agreement. What is that agreement? Whether to add or not. That is the agreement. If they okay, we can add. If they say no, we cannot add. That is how, because of the consensus only, we can achieve decentralization in the blockchain. So here I have highlighted this in the red point. The reason is that now we are implementing consensus algorithms in the cybersecurity whenever the decentralization is required. That is one of the emerging research now. And next, if you see, let me show you this one. As I said, we have 130 consensus algorithm. Out of 130 consensus algorithm, I have worked on POW that I would like to explain today. In POW, proof of work. So again in this what happened was, when I would like to, let me show you the picture again. This is the picture. So here there are multiple clients you can see here. What all the clients will do is, they would like to add a transaction into the blockchain. Okay. So here, out of the given nodes or out of the given miners are nothing but nodes are nothing but users. Out of the given miners, one miner wanted to add all the transactions into the blockchain. So that was placed here. Next, what this miner will do? This miner will create blocks to all the received transactions. Okay, and next. Now, what is the second part? So far, one part completed. Creating block was completed. So far, block was created with the multiple transactions by this miner. Now, how can you say that the data is authorized data? We cannot say directly without authorization. So, to do the authorization, we have to come this part. In this part, what we can do? The leftover miners on the network, they will participate in the puzzle. That is the work of the POW. As I said, every consensus algorithm having its own mechanism. Now in this POW, they will give one puzzle to the miners. Whoever will solve the puzzle, they can participate in the validation process. Okay, what is that puzzle? Puzzle is nothing but finding in nulls. It was there in the traditional block adding process also, but compared to there, here in POW, it was more computationally expensive. So the block adding process was difficult in POW. So whoever will win the puzzle, that person can add the block to the blockchain. This is the scenario of POW. Suppose this person won the puzzle. He could able to add block to the blockchain. This is a local blockchain, or we can also call them as a candidate blockchain. That person can add block to this blockchain. Now, after adding block to the blockchain, what he will get? He will get some reward in the form of bitcoins. Okay, like what we will get as a cash prize while doing online purchasing and all. Reward, he will get it. So finally here, by using this POW is one of the consensus mechanism in the blockchain. Through the consensus mechanism, we can achieve decentralization. And third point, while doing consensus, everybody has to participate in the either verification or validation process. And next point, whoever will add the block to the blockchain, they will get some reward. So here, you can work on multiple research directions. Now my question is, if you see the circle, how many miners we have? Number of miners. How can you say that the miner is trusted one? We cannot say, right? Because suppose now to the FTP everybody joined. How can I say that everybody was interested to listen to this FTP? I cannot guarantee. In the same way, in blockchain, everybody can join, but whoever having the capability to add a block, those only can add a block. What about the remaining? They may impose some attacks. So here the first research direction is, if you want to modify the existing POW, existing decentralization nature, you can modify. You can name it with your own name. And second research direction is, out of the given miners, to decide who is the trusted one, you can implement trust models. Okay. And third research direction is here. Normally in any blockchain, if you would like to add data, that will take 10 minutes. Suppose if it is more than 10 minutes, that is not a valid block. That we will be considered as a fork, fork, child block. So in that case, how to decide whether the added block was child or not? There is a timestamp, right? So here, by using timestamp, we can add block to the blockchain. That is another mechanism, another research direction. Now, if we look at the client, how many clients we have? 5 clients. So, who will come first? So here, means which client transaction will be added to the block first? That we don't know, right? So here we can implement scheduling algorithms. Like a first come first service, here we can implement all the scheduling algorithms to add transaction to the blockchain. Because if I am the first person, I will get the availability. Second person may have to wait till my completion, right? Because only one miner is there. That is one research direction. And the last one is reward. I think this reward mechanism was directly implied to gaming. You might know about game mathematical model for the gaming. In gaming, there are multiple strategies. Every time only one person will win and remaining person may lose, right? In the same way, if one person will get a chance to add a block to the blockchain, that person will get a reward. He having some winning strategy. The remaining persons are considered as losers. They're having losing strategy. So here, by using zero games, non-zero games, profitable games, we can design gaming theory into this reward mechanism. Okay, all these are the research directions, and this is one of the consensus algorithm. Through that, we can achieve decentralization. So in this way, we can integrate blockchain into cybersecurity. Next, here I have given a separate slide to tell you about how consensus secure the blockchain, how consensus will secure the cybersecurity. Because as I said earlier, cybersecurity is facing many challenges, right? So for example, whatever the challenge it is in cybersecurity, to that challenges, we can use this consensus algorithm to provide security to the data. Okay, mostly the problems are related to data integrity, and the problems are related to identity access management, and the problems are related to data sharing in IoT security systems, and finally the transparency in supply chain management. So whenever you might heard this, whenever you may heard this kind of buzzwords like decentralization, security, transparency, by the time you can apply this blockchain directly into the particular field. And coming to the previous slide, see, I think this slide is very resembles to the voice reference layer, right? In the same way, if you want to continue research in a blockchain, you can work on any one of the layer. I have worked on the consensus layer. Suppose if you're working on the application layer, here you can integrate this application layer with the computer networks. You can integrate this application layer with the cyber security also. For example, let me tell you, suppose if you are working on the application layer in the blockchain, means we are working on the DApps, decentralized apps development. During that process, if you integrate computer networks into this application layer, what happened was, on one side, by using blockchain, you can provide the security. On the second side, by using computer networks, we can implement any routing protocols. That is one aspect. Suppose if you are working with this on this application layer in combination with blockchain and cyber security, then by using blockchain, you can design decentralized applications followed by cyber security to make the system protection. Like that, you can work on any one of the layers, which is your wish. I think out of the 1.5 hour presentation, I have given multiple research directions. And now I have given multiple research directions. If you'd like to work, you can work on it. And coming to 2020-25, these are the publications we have in integration with blockchain and cybersecurity. Mostly are all related to application basis only, because we are integrating blockchain and cybersecurity into IoT. This is one application. Like that, every time you please find the application. So if the application is clear, then you please come to the features. If the feature is clear, then you please work on the grounded algorithm. Like that, you can continue research. So that's all about my presentation. And let me tell you once again what is the sequence I have maintained so far. Initially, I have started with cybersecurity. I have given various definitions for cybersecurity in various aspects, because we can deal cybersecurity in general aspect. We can for storing information. On the second side, we can see the cybersecurity on the attack side. And the third thing is we can see the cybersecurity on the governance policy like ICA. I have given all the three definitions. I have given all the research directions on the three aspects. Followed by I have given the benefits of cybersecurity, because every day human beings are connected to the computer. Every day human beings are connected to the computer to do various activities. In that, up to this point, I have given cybersecurity as a positive side corner. This is one side completed. And coming to second side, now in 2025, the burden on the cyber security is becoming more, because if you look at the evolution right from the firewalls to this zero trust models, the burden on the cybersecurity becomes more. It may be because of the population, it may be because of the technology dependency, or whatever the reason it is. Now, there are many challenges existed in the cybersecurity. How to overcome those challenges? That is the second corner I have covered. And again, in this corner also, I have given various research directions. Okay. And third corner is now in cybersecurity, apart from securing the data while sharing or while storing or while preventing attacks, whatever it may be, apart from securing data, we can include AI and ML only for the purpose of two things. The first one is for the automation, second one is for the recommendation. This corner I have covered, but again, my conclusion was those two things are not sufficient to make the cyberspace as a secure one. Not sufficient because I have given multiple challenges. For example, even though after including AI and ML into the cybersecurity, we have a problem of centralized failure, we have a problem of transparency, we have a problem of like a zero trust. So whenever these three things are required, we cannot directly rely on AI and ML in the cyberspace. So that's where I'm trying to bring blockchain into cybersecurity. Okay, and now this is another corner. Now my last corner was blockchain. I have given the definition for blockchain. I have explained how block was added to the blockchain. I have explained how decentralization is achieved in the blockchain. Because decentralization is one aspect of the blockchain. Apart from the decentralizations, there are number of features. But as per the time being, I have covered only how to achieve decentralization. In that aspect, to explain you how to achieve decentralization, I have taken consensus as an example. Okay, and in every consensus there are two phases: verification and validation. In block adding process, only one node will be participated. In block verification process, remaining nodes will be participated. Like that, we will achieve decentralization. That is what my conclusion. And I have explained only to one algorithm, that is POW, to achieve decentralization. Okay, and after this corner, I have included this consensus algorithm into cybersecurity. And lastly, I have covered how to integrate blockchain into cybersecurity on various applications. For that, I have given a separate slide, mostly on the basis of 2025 publications. So based on my observation in 2025, all the publications are on application aspect. And let me tell you one personal experience what I have. Whenever you would like to publish blockchain papers, we will not get journals directly. Of course, we have some journals, but those are indexed in ESCI and not indexed in Q2 also. So it is better to work on application only. So application in the sense, we need to integrate blockchain with the quantum, or we need to integrate blockchain with cybersecurity. And again, based on the research, the definition is going to change. Okay, so here we are going to integrate cybersecurity into the blockchain only to address the challenges in cybersecurity. What are the challenges? Single point of failure, decentralization, transparency. Because of the three, we are using blockchain. In the same way, we should be in a position to analyze what are the challenges in current research. Suppose if we bring new research into this picture, how we can overcome. That's what we should clear at every point of time whenever we do the research. Anyhow, I'm unable to talk with the participants. So in the last slide, I have given my office address as well my phone number and personal mail also. If you have any doubts regarding this presentation or any related to blockchain, you please text me. I'm working on blockchain, and now I started to work on the quantum computing also, because on one strong point that quantum computing can break the blockchain. On this basis, I would like to work on how quantum computing can break the blockchain hash value. In this, I'm working now in this line. So whatever the doubts you have, you please ping me. But anyhow, let me conclude. As we come to the conclusion, I'm really happy for sharing the insights of cybersecurity and blockchain together. And over 1.5 hour, we had discussed important topics in cybersecurity, from the basics like CIA policy to advanced areas such as AI, blockchain, and I have given many research directions. So finally, I can say this FTP gave me a platform to connect with all the participants, even though it is indirect connection. But I have shared all my ideas. I thank to all the participants for joining to this live stream. Please connect me to my office address if you really needs, if you really would like to share your thoughts, and you can call for any kind of questionnaire after this session also. Thank you all. Thank you all of you. We'll see in further FDPs. Whenever I have the chance for the next FDP, I will be into the specific problem directly. Now I have given a broad area of cybersecurity into blockchain, but in the next time I will be into a specific problem directly with the simulation, if possible. Thank you once again. Thank you to the all organizations also. Thank you so much.
Thank you, ma'am, for your wonderful session, ma'am. On behalf of Computer Science and Engineering Department, Guru Nanak Institute of Technology, Hyderabad, extend our heartfelt thanks to today's resource person, Dr. P. Naga Sravanthi ma'am, for sharing valuable insights and deep knowledge on cybersecurity threats and also their challenging role to every individual as well as organizations. And also, what is the significance of blockchain and why we need blockchain in cybersecurity area also. Especially, Madam explained some real applications, Swiggy, Zomato, and a case study on healthcare domain, and also transactions, how transactions happen with the blockchain. So your session was very wonderful, madam. And also, your session will definitely provide a path, madam, for doing a research work. And my sincere thanks to all participants, which made this session truly successful. And thank you.